So this just becomes cosine of x. For sine, the negative comes out front, so we have negative sine x minus cosine of x. There is no negative in this one, so it just stays sine of x. So we really have a negative minus a negative, so it'll be negative 2 something. Well, cosine over sine, that's going to be cotangent. So negative cotangent minus cotangent is going to be negative 2 cotangent x. And it could have worked out if you just replaced each of these with cotangent. Then you have negative cotangent minus cotangent, so you didn't have to skip right to there. Any questions on that bell work? Yeah, Luke?
Wait, how did you get to the cotangents again?
Because cosine over sine equals cotangent. It's one of our identities. We should have memorized for today, because we could have a quiz. We're not taking a quiz. But each day we go by, there's more likely we're going to have a quiz. So tomorrow, it's even more likely than there would be one today.
Wait, what? Wouldn't it have... Oh, so is it negative cotangent because it's negative sine?
Yeah, negative cotangent minus cotangent equals negative 2 cotangents. All right, any questions on that? All right, questions on the homework? I'm actually going to wait to check the homework tomorrow, just in case you got caught in PSAT land and you stressed out and didn't get it done. But yeah.
John, number 38.
Number 38. All right, do you have a specific question?
I don't remember what the actual answer was supposed to be, but I got something very, very different.
What did you get?
I got negative 2 over cosine.
Okay, let's look at this really quick. So I need to pull, either that negative comes out front or it kind of disappears. Well, cosine x equals cosine negative x, so the same thing applies for secant. So that means I can rewrite this as just secant x minus secant x. I'm not going to try converting anything because something minus itself is just going to be 0.
Oh, I see. Oh.
I think you try to make it way more difficult than it needed to be. Yeah. Did you pull the negative out front?
Yeah, I did.
Yeah. That's why we got to practice those, right? Whether either you get rid of it or you get pulled out front. It changes your answer completely, because if you'd pull this out front, it becomes a much more difficult problem. All right, other questions? That's it? Just one question? We got the rest?
You're going to go over one?
No. If there's no question, I'm not going to go over them.
Can you do 27?
Can I do 47?
27.
27? Any reason why I'm doing 27? Do you have a question on it, or?
Yeah, I didn't really.
Okay. All right, so we have cotangent alpha. So the first thing I'm going to do is I'm going to say tangent alpha equals a negative 3. So I have one of them done. Then I'm going to see what quadrant I'm in. It says it's from I don't have that up yet. It's from negative pi over 2 to 0, so that's going to be quadrant 4. Because negative pi over 2 would be straight down all the way to 0, so that would be quadrant 4. In quadrant 4, we have all students take calculus, so that means cosine and secant will be positive. All right, I'm given cotangent. I could also use tangent. I'm going to go ahead and use let's go ahead and use cotangent. So we're just going to go to our identity sheet and find one of the 3 things that has cotangent in it. Which one has cotangent in it? Yeah.
1 plus cotangent square of x equals cosecant square of x.
So that's what we're going to use, because it's got cotangent in it. And we're just going to take cotangent and plug it in there. So then we're just going to have 1 plus, technically it's a negative 1/3, but it's not going to matter because we're squaring it. And that's going to equal cosecant squared x Doing some simplification, we are going to take the square root of both sides. We'll have plus or minus the square root of 9 over 9 plus 1 squared is 1, 3 squared is 9. That's going to give me cosecant x. You okay? Oh, I thought I saw a hand up. No, okay. Alright, so that's just going to be plus or minus, and you could do a lot more of this in your head, of 10 over 9 still equals my cosecant x. So cosecant x is really just going to equal the, let's just leave it as the square root of 10 over 3, and it's going to be negative. And since I know the cosecant, I know the sine is the reciprocal. So sine x is going to be negative 3 over square root of 10. Alright, so I have cosecant, I got sine. The only thing I need next is cosine. So you're just going to have to go through, and almost all of these you have to use sine squared plus cosine squared equals 1, which you could have simplified to say, well, cosine is going to equal the square root of 1 minus sine squared x. And you would just take this, plug it in, and solve for cosine. Okay? Did you sure?
Yeah.
Okay. I don't want you to just say yeah and go, I have no idea anything. Hopefully he doesn't put this on the test, because this is on the test. I guarantee there's at least one problem like this on the test. So now's the time to ask if you don't understand how I did something. Does that make sense to everyone? I didn't see a ton of people writing it down, so I'm hoping either you did it and got it, didn't do it and don't want to have it out to show that you have a blank thing in your, or you got it and you don't need me to go over it. All right. Hopefully it's a, I got it, I don't need you to go over it. All right. Then we'll go on to today's lesson. Today's lesson is where we kind of ramp up simplifying problems. So these are going to be more difficult. All right. Some might be just as equal. These are just giving you some hints you can use if you can't figure out what to do next. So do not just try these right off the bat and just say, okay, Mr. Paving showed them in class, I have to do this every single time I see a problem. All right. One of the methods that I'm showing you right now is, remember, this is kind of our last resort. I can't simplify any further. Let's go ahead and push these fractions together. Because right now I have 1 plus sine theta. I can't simplify that any further. All right? Everything that deals with sine, with all of those identities, is sine squared. Right? Because sine squared plus cosine squared equals 1. I need sine squared. So I can't simplify this any further as written. So our goal is just to push them together. All right, how we're going to push them together is, let's look at just kind of an obscure little fraction problem. So say I have 2 over 3 plus, I don't know, 3 over 7, right? I need a common denominator. We can either just look for that number that they both go in evenly, or we could take kind of a shortcut and multiply one fraction by the other denominator on top and bottom, and multiply the other fraction by the other denominator, top and bottom. So all I did is, 2 sevenths, I just multiplied by 7 and 7. For this one, I multiplied by 3 and 3. And we are guaranteed, as soon as we do that, to have a common denominator, and be 14 over 21 plus 9 over 21. Now I can solve it. So if I can't physically see what goes into both of them to make a common denominator, just multiply by the other denominator. But make sure you do the top and bottom, right? Because I'm actually multiplying by 1. Because it's 7 over 7. This is 3 over 3. So the same principle is going to hold up here. I can't really see what is going to go into this. So all I'm going to do is I'm going to take the denominator of the other one, which is 1 minus sine theta, and multiply the top and bottom by the other fraction. Then I'm going to take this denominator and multiply it by the bottom and top of the other one. So fully written out, we'd have something like this. I would have 1 minus sine theta over 1 minus sine theta, and I'm just going to use that to multiply by that first fraction. That first fraction is 1 over 1 plus sine theta. So all I did is I took the other denominator, multiplied by the top and bottom of this one. Then we add, and we're going to do the same thing with the other denominator. Our other denominator is 1 plus sine theta, so we'll have 1 plus sine theta over 1 plus sine theta, and we're going to multiply it by the other fraction. So that's times our original fraction of 1 over 1 minus sine theta. Now, as soon as I do that multiplication, we are going to have a common denominator automatically, and then we're able just to push those two things together. So let's go ahead and do the multiplication. I'll put equal signs on the left-hand side. So this one, the first fraction is 1 minus sine theta times 1, so we just have 1 minus sine theta on top. On the bottom, I have 1 minus sine theta times 1 plus sine theta, which is just a difference of squares. All right, so I don't have to go through the whole FOIL thing. It's just a difference of squares. So on the bottom, we're just going to have 1 minus sine squared theta. Plus, on top, I have 1 plus sine theta times 1, so it's just 1 plus sine theta. On the bottom, once again, it's a difference of squares, so it just becomes 1 minus sine squared theta. Now when I push these two guys together, we add their numerators. The denominator stays as 1 minus sine squared. So we have 1 plus 1, which gives me 2. So that's going to equal 2 on top. I have a negative sine theta and a positive sine theta. That's just going to turn to 0. So I have 2 plus 0, or just 2. And that's over 1 minus sine squared theta. Most of the time that I have sine squared or cosine squared, we can reduce it a little further, especially if there's a 1 there. So I have 1 minus sine squared theta. So we should have already kind of thought about, remember, everything boils back down to sine squared plus cosine squared equals 1. I just want to manipulate this so that I have 1 minus sine squared. Because right now I just have sine squared plus cosine squared. In order to have 1 minus sine squared, I need to subtract sine squared from both sides, which tells me that cosine squared equals 1 minus sine squared. So 1 minus sine squared just equals cosine squared. Just equals cosine squared. So this is just 2 over cosine squared theta. And then to go one step further, anytime I have cosine, sine, tangent, anything on the bottom, we're talking about reciprocals. We're always talking about reciprocals. If I just have a number over one of my trig things, we're going to start thinking about reciprocals. So the reciprocal of cosine is going to be secant. Secant's the same thing as 1 over cosine. Well, I have 2 of these, and they're squared. So 2 over cosine squared theta is actually going to equal 2 times secant squared theta, and then I'm done. So generally speaking, 99.999% of the time, if you have a fraction, you can reduce it to something. All right, your answer isn't going to be a fraction, because usually we can go to the reciprocals of it. Any questions on any one of those steps? Yep. Yeah.
I don't get how it would equal 2 secant squared, because if it's the reciprocal, wouldn't it be like half secant squared?
No, because I can't go to another slide, so I'm just going to throw it up here just so you can kind of visualize it. All right, I can rewrite that as 2 times 1 over cosine squared theta. I can just pull that 2 out front, because it's technically 2 over 1.
Okay.
All right, and now that it's 2 times, it would just be 2 times whatever 1 over cosine squared is, which is secant squared.
Okay.
Okay? The only time it might be 1/2 is if the 2 was on the bottom. Yep. Good question. All right. So that's if I can't reduce anything in fractions. Obviously, try to reduce things in fractions first. See if you can get rid of fractions another way. Because sometimes fractions just will cancel out and you don't have to push them together. But if you're stuck, that's your kind of last resort. Try to push them together. All right. This is another one that's kind of a last resort. All right. I get down to this. All right. I get down to this. The only thing I could possibly simplify is that cosine squared y. So we're not going to write this down. Just follow my thought process here. Don't write any of this down because it's going to take up space. But if I was actually solving this, I would think of my, cosine squared plus sine squared equals 1. So I could rewrite cosine squared as 1 minus sine squared. We're not writing this down, right? Not writing this down. This is just my thought process. So I could rewrite this whole thing as 1 minus sine squared over 1 minus sine. Did I really simplify anything? Does that look easier? Does that look more simple than the other one? It does? This looks a lot more simple than this one?
Yes.
I would disagree. I think this is even more complicated because I actually added a 1 minus, because I can't go anywhere else in here because these don't divide into each other evenly. Yes?
Isn't it a perfect square though?
Is this a perfect square? Yeah, so we could break that apart. So that might be one method. But if you didn't see that, you just got to here. And we are going to deal with perfect squares. Yeah. But if you didn't see that was a perfect square, you'd kind of realize that maybe I can't simplify it as is. All right, if you didn't see that one little trick, you might think, well, I can't simplify as is. So if you were ever stuck with a fraction, and you can't quite get rid of it, and no matter how you manipulate it, you can't quite get rid of it, and you have something like 1 minus sine y, or 1 plus sine y, or 1 plus cosine y, or 1 minus, something like this, we're going to think about a perfect square. And what's going to help us with that is multiplying the denominator by its conjugate. So if I can't do anything else, we're just going to multiply the denominator. Can you pick up your head, please? We're going to multiply the denominator by its conjugate, which if it's 1 minus sine y, the conjugate is 1 plus sine y. All right? Let's just change that plus and minus. So in this example, we're going to take that cosine squared y over 1 minus sine y. And I'm going to multiply the denominator by the conjugate, which is 1 plus sine y. But that means I need to multiply the top by the conjugate, which is 1 plus sine y. All right, and that's just going to equal, I'm going to leave the cosine, I'm not going to distribute it, because it looks like it's going to be complex if I distribute it. So we'll have cosine y times 1 plus sine y. All over, since this is a difference of squares, it's just going to be 1 minus sine squared y. But I have 1 minus sine squared y. What can I rewrite 1 minus sine squared y as? Luke? Just cosine squared y. So this is just going to equal cosine squared y times 1 plus sine y all over 1, not 1, just cosine squared y. My cosine squares are going to cancel out. And I'm just going to be left with 1 plus sine y. And that is, in fact, as simple as it can get. Because anything with sine in our identities is either reciprocal or it's got to be a square. All right. This is not a fraction, so I can't worry about using a reciprocal. And it's not squared, so I can't worry about using sine squared plus cosine squared equals 1. That is my final answer. Yeah. No, you were just stretching, weren't you?
Yeah.
And as soon as I pointed, you're like, ugh. Did you also have a question? Yeah.
Like, what happened when you had 1 minus sine squared y in the denominator, and then you're like...
I rewrote it as cosine squared. Because anytime you have sine squared y, you're going to think back to cosine squared plus sine squared equals 1, right? So maybe I'll do it off on the side. Did I do it up here? No.
Because one, they're equal to each other.
Yeah, because you just go back to your sine squared plus cosine squared. Try to set it up so you have 1 minus sine squared, which happens to just equal cosine squared. You should always be doing that check if you have sine squared or cosine squared and a 1. All right, a 1 and a cosine squared or a sine squared always tells you there's a good chance I can rewrite this as a sine or a cosine squared. Okay, and so that was my tip off here. I have 1 minus sine squared. So I'd think about that sine squared plus cosine squared. How do I manipulate it? Yeah, it's going to equal cosine. Does that make sense where we got it from? Okay. Nothing should be magical. All right? Nothing should be like, oh, if I see that, just put this down, because that's what we did every time. All right? Everything should have a reason behind it. All right, the next one is, what happens if I have cosecant to the fourth minus cotangent to the fourth? What I want you to do is look at your identity sheet, and I want someone to tell me which ones are to the fourth power. Someone tell me ones that are to the fourth power.
None.
Yeah, if you studied these, you'd already not even had to turn the page. There is nothing that's to the fourth power.
Yeah, I don't remember that.
Yeah, I didn't study that enough. Remember, we could have a quiz tomorrow. There's nothing to the fourth power. So the only thing I could do is rewrite it to the second power. That's the only thing that works. I'm just going to put a little note off to the side. All right, I'm going to put a little note to myself off to the side. If I ever give you something like a squared minus b squared, and I tell you to factor it, you would rewrite this as a minus b times a plus b. All right, that's a way to rewrite it. Yes?
Why isn't there like a plus 1 or something in that equation?
In this equation or
Yeah,
this equation?
In that one.
Because it's fine. We don't need it. We're not going to need it. Nothing's missing. All right, so if I have that, I'm going to rewrite it as that. Now, going the other way, let's say that I have a squared minus b squared times a squared plus b squared. It's still a difference of squares, because my a squared is the same on either one, and so is my b squared. So I could rewrite that as a squared squared minus b squared squared. And if I'm ever squaring a square, all right, if I have a power to a power, you multiply them. Even if you got this wrong and you added them, you still get the right answer, but you do multiply them if you have a power to a power. So this is really a to the fourth. So that's just going to be a to the fourth minus b to the fourth. So if I ever have two things that are the exact same thing and there's a subtraction sign between them, I'm always going to ask, can I use perfect squares to solve this? And David saw it in the first one. A prime example of that, you don't need this one down, but like 1 minus sine squared is actually a difference of squares, because it's actually 1 squared minus sine squared. That would be a difference of squares, and we could rewrite that. But that isn't the case here. We now have cosecant to the fourth minus cotangent to the fourth. So it is a difference of squares. It is still a difference of squares. So we're just going to rewrite it as cosecant squared x minus cotangent squared x times cosecant squared x plus cotangent squared x. Now I have to go to my identity sheet, or if you have these memorized, awesome. And we got to think about the one that's cosecant and cotangent. All right, it's one of our Pythagorean big three. is always the ones we pretty much go to with squares. Can someone tell me the one that would work for this one? Which identity would work for this one? I talked to you. Someone new. Someone new that's just sitting there not doing any of the work, not even turning to the page that has identities. And just like someone else is going to tell me, because on the test I'm sure someone's going to give me the answer as well. Someone tell me the identity that has cosecant and cotangent in it. Yeah, Jack.
1 plus cotangent squared of x equals cosecant squared of x.
Okay, so we have 1 plus cotangent x squared equals cosecant squared x. It doesn't quite fit either one of those situations, so I'm going to manipulate it. All right, these both have cosecant followed by cotangent. So I'm going to subtract cotangent from both sides, so I can rewrite this as 1 equals cosecant squared x minus cotangent squared x. So that means anytime I see cosecant squared x minus cotangent squared x, I can replace that with 1. So that's right here. I'm going to replace that with 1. So that's just going to be 1 times whatever we have, so we're just going to equal, I guess I'll write it all out, cosecant squared x, so it doesn't look like it just disappeared, cotangent squared x, and that's just going to equal cosecant squared x plus cotangent squared x. And you are actually done there. You could go a little further by, figuring out what cosecant is and then try to match it up with cotangent, but it's not going to make it any simpler. This is as simple as it gets. All right? Because these don't match up here, we're done. We are done. The only one we're going to replace with 1 is the one that replaces, and then we are done. Any questions on that one? Look out for those. Those are sneaky. Difference of squares are sneaky because they just kind of show up in weird ways, and you're always trying to manipulate it. If you have a negative sign between two things, think difference of squares. Yeah.
You just said it. So.
Oh, okay. Like when to recognize it?
Yeah.
I always look for, is there a negative sign between them? Look to see if you can use a difference of squares. All right? And remember, the homework for tonight isn't just going to be replicas of these problems. Some of them might be a little bit. Other ones you have to use completely different tricks on. All right? These are just common tricks that if you can't simplify a certain way, if you come to a dead end, try these. All right, one more. I got sine cubed x over sine cubed x minus sine of x. Oh boy, that's a lot of signage. Factoring. Factoring is a common mistake people are going to make. You're going to make this problem way too hard. And what I'm going to notice on this one is I have nothing but signs on the bottom. So factor out a sign and see if that helps you. All right, so on the bottom I can pull a sign out of here. I could pull a sign out of here. So that's the first step I want to do. Before I even try anything else, I'm going to try to factor because I have so many things that are the same on the bottom. So I have sine cubed x. All over, I'm going to factor out a sine of x. So that's going to give me sine squared x minus 1. Sine squared x minus 1, that's something. That's got to be something. But let's get to that. Yeah? Could you pull a sine all the way into the front? Is that what you're saying? Yeah, you could. Why wouldn't I? Because for this example, because most of the time you're not going to have a problem that you pull sine out of everything. You're just going to work on one level at a time. That's why you don't make mistakes. All right, what happens is sometimes you pull it all out and you just drop it. And you just make it disappear. All right, if I would just pull sine out and just drop it, yeah, just stick on one level at a time. All right, don't try to do too many steps at once. All right, so that means my sines will cancel out, and I'll just be left with sine squared on top. So we're going to have sine squared.
What happened to the minus sign? That's on the bottom.
Oh, I factored it out. I pulled that guy out. Because if I distributed this, I'd have sine cubed x minus sine x.
Oh, yeah. Okay.
I just factored it out. Basically, you divide everything out. All right, so that gives me sine squared x all over sine squared x minus 1. What can I rewrite sine squared x minus 1 as? Yeah, careful.
It would be negative cosine.
It would be negative cosine squared. Perfect. Over negative cosine squared x. I got sine over cosine. That's either going to be tangent or cotangent. Since sine is on top, it is going to be, who's got a guess?
Tangent.
Tangent. It is going to be tangent. Because for cotangent, cosine needs to be on top, or cotangent's alphabetical order. So this is going to equal negative cotangent squared. Oh, wait, what did I do?
Tangent is
Yeah, tangent. I said it, and then I said the wrong thing. I confused myself by talking myself through it. Yeah, it should be negative tangent squared x. Does everyone see why it's negative cosine squared x? Or is that your question?
That was my question.
Okay, so we have sine squared minus 1. So once again, if you get confused with these, write it down every single time, because I'm doing it in my head. Like, I'm doing this in my head. I'm writing down sine squared x plus cosine squared x equals 1 in my head. Because, yeah, the more times we do this, I memorize what things are, but every year I just go back to sine squared x plus cosine squared x. I need to have sine squared x minus 1, which means I need to subtract 1 from both sides. I need to get rid of the cosine, so that means I need to subtract cosine from both sides. So just manipulating this thing, I would have sine x squared minus 1 equals negative cosine squared x. Plug it in, it's into place. And I think everyone that gets it right, who gave me, Aaron, you gave me the negative. Who gave me the negative cosine? Did you kind of work this out in your head, or did you have it memorized?
I looked at the sheet.
Oh, okay.
If you look
That's
at the sheet, then you just flip it.
yeah. But you should always be looking at something, right? You should always go back to sine squared plus cosine squared, because the sheet won't be on the test. All right, so just practice using sine squared plus cosine. Luke, does that answer your question? Okay. Good, 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 good. All right, homework. Homework, skip the first 4. Just don't do those. I don't like them. I'm not going to put them on a test. We're just going to say no. Just no. I do want to do one quick example with you, and you can put it on the bottom of the page. It should help you. And otherwise, I'm going to get this question immediately tomorrow from the homework. Let's say I have sine squared x minus cosine squared x. Let's say I have that. The problem you're going to have is you're going to say it equals 1. That does not equal 1. Sine squared plus cosine squared equals 1. But it doesn't mean we can't simplify it. How we can simplify this is we can either turn the sine squared or the cosine squared actually into cosine or sine or vice versa. And how that would work is if you go back to sine squared plus cosine squared equals 1. And I wanted to rewrite this all in terms of cosine. Well, I would just say, well, guess what? Cosine squared just equals 1 minus sine squared. That's a fact. So you could use that fact
So would sine squared equal?
to replace that. So we'll have sine squared x minus 1. Well, I got to put in parentheses because we're subtracting 1 minus sine squared x. Distributing that negative sign, it would equal negative 1 plus 2 sine squared x. So it is possible, although this is not, I would never say simplify this, because neither of these are more simple than the other one. It's just you can use this to help you move forward in a problem, all right? If by itself, this is all the way simplified, all right? This is equally as complicated, so it's not considered simplified. But there are going to be problems in the homework where you have to do this to actually solve the rest of the problem, all right? There's going to be more attached to it. But this is good to know that if you ever have sine squared, you can replace it with cosine. If you ever have cosine squared, you can replace it with sine. Even though it might make it a little more complicated for a second, it usually fixes the problem later. All right? So there's multiple different methods we have. We're skipping the first 4 problems, and we're going to work on the rest.